I'm Kyle Smith, and we're getting down to the brass tacks and hard facts of the fire pump room. As you make your way into a fire pump room during the pre-planning process, there's a couple of key things that we want to identify as we gather the information for a given facility. One of the main ones as we walk in is the general water flow through the room. That starts with the supply. In this particular room, we have the municipal supply coming in from my left into the fire pump, through the fire pump, which generates that additional pressure necessary, off into the discharge side and up in through various valves and plumbing to the building. A good way to identify the flow of the water through the room is through locating check valves. In this installation, we see two check valves, one in the bypass loop and one on the discharge side of the pump. And those valves have indicating arrows showing the direction of water through the valve. Another way that you can identify the direction of that flow on this type of fire pump, there's an arrow in the pump casing itself. That arrow indicates the spin of the impeller in that pump casing. Typically, that spin arrow will point towards the supply side or the municipal side of the fire pump, thereby indicating that the water is going through the pump and out towards me. Once we've identified that, we kind of have a better idea of how the room is laid out and to be able to troubleshoot later. Now let's look at some of the individual components we find. One of the key pieces of information to gather ahead of the fire is the hydraulic plate. There's going to be lots of different numbers based on the design and setup of this pump, but a couple of the key numbers that we want to identify: the rated capacity of the fire pump. It will tell us the maximum GPMs that that pump is designed to deliver. Additionally, on the plate is the maximum pressure. That's the maximum amount of boost that that pump can generate. If we take that and add it to the pressure coming off of the municipal supply from the street, that gives us the maximum discharge pressure we would ever expect out of this pump installation. That's referred to as the churn pressure, or the pressure at zero flow. Fire pumps operate at a fixed speed. They're never going to go any faster. That's the maximum pressure they can deliver. Let's look at some other components like the different valve types. In this particular installation, we have a traditional outside screw and yoke valve, commonly referred to as an OS&Y. If the stem is out, it indicates that this valve is open. Another common valve we see are butterfly valves, like these. They have an indicator that shows us that that butterfly is in line with the pipe, allowing water to flow through them. All valves on a fire protection system are going to be indicating, meaning we can look at them from the outside and determine if those valves are open or closed. Another type of valve we want to identify is a pilot-operated pressure-reducing valve. These valves will not be on every system, but if you do have them, we want to know that ahead of time. They have a maximum set discharge pressure that will not be exceeded. It won't matter how much pressure you pump in at the fire department connection, it will not deliver any more than its set pressure. Every fire pump room is also going to have a jockey pump. That's the maintenance pump. It's the one that's used to maintain pressure in the system if there's a small leak or drop in system pressure. A jockey pump will not keep up with the flow of one sprinkler, so if a sprinkler activates or we've opened a hose valve, it will not be able to keep up. That pressure drop will start the main fire pump. The other component we want to identify in the fire pump room is the fire pump controller. Those are going to be the large red boxes on the side of the wall that are used to control the automatic and manual function of the fire pump. Do not open an electric fire pump controller. They have extremely high voltage inside, they are dangerous, and there is no need to open them. All of the manual and automatic functions can be controlled with the control box closed. The other primary driver we find are diesel-driven fire pumps. They use batteries to start the engine, similar to your vehicle. Those are going to be low voltage controllers and may need to be open to operate the pump. If you're not sure what to do, follow the directions. The directions for how to operate the controllers will be on the door. You can never go wrong just following the directions that you see on the door. All fire pump rooms are a little different, but will have these similar features. The more information that we can gather during this pre-incident planning process, the more information we'll have to use and reference on the day of the fire.